town. I'm like,
The ones in Rhino is looking long.
30-minute one, yeah.
Well,
That's a lot.
wait, what is this? What are the ones without triangle?
I know. And then I'm like, you're laughing and I rewind. Laugh.
So here's what I want to say about this. You got to be really careful when you're setting these up. I always say you should start with the one they give you. This is like the initial value kind of thing. So that's going to be my lower bound, which makes sense because it's smaller anyway, right? And then I end with my upper bound, or the one I'm looking for. Even if it's out of order, I do that because we have the property that says you can switch the order and pull negative out, and so it works out if you have to flip it over anyway. But this one, we don't know the integral from negative 2 to 2. Do you agree with that?
Yes.
So this would be capital F of 2 minus capital F of negative 2. So this means we have to do some area. We have to go back into that geometry life that you felt like you could forget.
Oh, that is great.
It's just a rectangle and half of a circle. Or you could do half, you could just do 1/2 of it and then double it, but then you have to do 1/4 of a circle.
Let's not.
I forget half.
We already did that. Circle part. We already did a quarter of it.
But we only
Well,
do.
multiply it by 4.
That's right, I'm just going to do it again. So, area of a circle is pi r squared. So if you're taking half of it, you just divide by 2. If you're taking 1/4 of it, you divide by 4, right? I believe in you. So the radius of this circle is 2. So that's pi times 4 over 2, or 2 pi. Yes? Which makes sense. Because we said 1/4 of it was pi. Plus, if I'm going to do the area of this rectangle, that would be 1, 2, 3, 4 by 1, which is 4.
Yes.
I'm going to dig up today while you're working the videos that my calculus kids made last year because they didn't know the area of a triangle or the area of a circle, and that was part of the video that I had a breakdown because they didn't know area of a triangle.
The area of the triangle.
2 pi plus 4. And again, they give us F, capital F of negative 2, which is negative 2, so that really becomes plus 2. Yes? So then I subtract 2 over, and I get 2 pi plus 2 is what this equals. This is kind of getting us close to this next big idea that we can find distance traveled using integration, given an initial starting point, and finding the total distance traveled or the net distance traveled. Like that's our next big thing that we're going to do. This is like a preview. That's why I paused for a minute, because I'm like, I don't think we watched the video on how to do that yet. But you don't even need to know that that's referencing distance, because you can just use the fundamental theorem of calculus. Part 1.
Yeah, particle motion.
Particle motion. Okay, so here's the plan for today. Homework day 50. Hopefully you can get through most of this. And then after this is the free response questions. And so my hope is you do homework day 50 in class today and you actually try some free response on your own, because that's kind of your review for your quiz. And then tomorrow I'm going to leave you a video. I'm not going to be here tomorrow. I'm going to leave you a video going through the free response, but I can't stress enough that you should try them first yourself and see what you can get through, because if I'm just doing it for you, I can't do the quiz for you. But I'm going to leave you a video for that, and then Wednesday, you're going to have a quiz. I'm probably not going to be here. Yes. So if you have questions over what I leave you, or questions in general, email me, or remind message me, or put a thing on Google Classroom, and I'll check it. But hopefully we get through most of this homework today. And the quiz, this is our first quiz of this unit, right? So go back. It's going to have antiderivatives on it. It's going to have the fundamental theorem of calculus on it. It's definitely going to have some area stuff on it. And I'll even look right now and make sure whether it's calculator or no calculator. I feel like it's going to be no calculator, because your calculator can do all the work for you, but No calculator. Look at fun. Imagine you being like, oh my god, I jumped to you. This is where the property of breaking up addition subtraction. You don't have to always break it up, but when they give you the function value, you don't have to do f of b minus f of a, because you know the integral of negative 2 to 4 of 3g of x, you know the value of g of x is 4, and you can just say this is 3 times 4, which is 12. But that's separate from this, so you can imagine rewriting this of saying this is from negative 2 to 4 of x, and when you take the antiderivative of that, it's x squared over 2, and then what do you have to do?
Plug in 4 and
You have to do the f of b minus f of a part and add it to 12. So you're going to have 12 plus doing that part. So that's where you have to, you don't have to show separating it, but if it helps you, like, separate it, because you know what the value of f of x and g of x are, but if they throw in some other x in there, you actually have to do the fundamental theorem of calculus. Part 1.